Imagine walking into a grand concert hall, where instead of musicians, there are fundamental particles of the universe playing an eternal symphony. This is the heart of string theory, a revolutionary concept in physics that suggests all particles are not point-like dots, but rather tiny vibrating strings. Just as different musical notes emerge from varying vibrations of guitar strings, so do the diverse elements of the universe arise from these microscopic strings. String theory is not merely a theory of particles, but a potentially unifying picture of the universe, providing a framework that encompasses all forces and matter. The beauty of string theory lies in its simplicity and its power to unify. Historically, physicists have sought a single theory to explain seemingly disparate aspects of the universe. String theory proposes that every force and particle corresponds to different vibrations of the same basic strings. This elegant model captures the imagination and invites us to rethink our understanding of the physical laws that govern everything around us. String theory is as poetic as it is scientific. It suggests a universe that is dynamic and alive at the smallest scales imaginable. Each vibration in the string corresponds to a different particle, making the universe akin to a cosmic symphony where strings are continuously vibrating into existence, the cosmos as we know it. This perspective not only deepens our understanding but also connects us more profoundly to the very fabric of reality. As we delve deeper into string theory, we uncover more than just the nature of particles. We begin to see the universe as a fluid, interconnected entity, more akin to music than to the machine-like structure classical physics once suggested. It's a shift that might not only revolutionize our understanding, but also the way we perceive everything around us. To truly grasp string theory, imagine plucking a guitar string. Depending on how it's plucked, the string vibrates in different ways, producing various musical notes. Similarly, in string theory, the universe's fundamental particles, like electrons and quarks, are thought of as tiny vibrating strings. The nature of these vibrations determines the type of particle, its mass, charge, and role in the greater cosmos. This idea introduces a fascinating layer of complexity to our understanding of the microscopic world. Different vibrations allow strings to appear as different particles to an observer. This is akin to how a single guitar string can produce a C note, a D note, and so on, depending on how it vibrates. In string theory, each type of vibration corresponds to a different fundamental particle. Thus, what appears to be a diverse universe is actually the result of varied vibrations of the same fundamental strings, a truly elegant explanation of nature's multiplicity. Moreover, the concept of vibrating strings challenges our conventional views on the vacuum of space. Traditionally viewed as empty, space, according to string theory, is alive with strings vibrating in various quantum states. This shift in perspective is profound, suggesting that what we perceive as empty space is actually a cauldron of dynamic activity, the ground state of the universe buzzing with string vibrations. This analogy not only simplifies the complex mathematics behind string theory, but also makes it more accessible. By understanding that these strings can stretch, merge, or split, much like musical notes can be varied, we begin to see the flexibility and dynamism of the universe. It's a concept that bridges the gap between the tangible and the abstract, between the seen and the unseen. One of the most breathtaking ideas that emerge from string theory is the concept of parallel universes, existing just millimeters away, yet completely invisible to us. These universes are not science fiction, but potential scientific fact, according to string theory. They exist in dimensions we cannot perceive simply because they vibrate at a different frequency, much like a sound we cannot hear because it is beyond the range of human hearing. Imagine a world where every choice you don't make exists in a parallel universe. String theory posits that these parallel universes vibrate at frequencies distinct from our own. This means that they are as real as our own universe but remain invisible and intangible because of their unique vibrational states. The implications of this for our understanding of reality are profound, suggesting that our universe is just one of many in a vast, possibly infinite cosmos. The concept of extra dimensions is crucial in string theory. While we experience only 3 spatial dimensions and 1 of time, string theory suggests that there are additional hidden dimensions that could be as real as the dimensions we perceive. These extra dimensions are compactified, meaning they are curled up so small that they are imperceptible to us, yet they influence the fundamental aspects of the universe. Understanding these hidden dimensions and parallel universes could unlock new understandings in physics, providing explanations for phenomena that are currently mysterious. For instance, the nature of gravity, the behavior of black holes, and the properties of dark matter might all find explanations within the framework of string theory. This opens up a universe of possibilities, literally expanding our view of reality to scales and dimensions previously unimaginable. Section 4. The Future Unveiled, Implications of String Theory. The implications of string theory extend far beyond the academic halls of theoretical physics. They reach into the very way we conceive of our universe and our place within it. As we continue to explore the nuances of string theory, we're not only deciphering the language of the cosmos, but are also paving the way for revolutionary technological advancements. These could include new forms of energy, novel approaches to quantum computing, and even the theoretical possibility of time travel or interdimensional communication. The pursuit of understanding through string theory also has profound philosophical implications. It challenges us to reconsider our notions of reality and our understanding of the universe's structure. If multiple dimensions and parallel universes do exist, the philosophical and existential questions that arise are as significant as the scientific ones. What does it mean for our understanding of existence if there are infinite versions of ourselves living out alternate lives in parallel universes? Moreover, string theory encourages a new era of collaboration among scientists. As the theory requires a blend of quantum mechanics, cosmology, and particle physics, it fosters a multidisciplinary approach. This collaboration could lead to the next major breakthrough in our understanding of the universe, much like how the theory of relativity and quantum mechanics revolutionized science in the 20th century. As we delve deeper into the microscopic world of strings, we are also expanding our view of the cosmos to include incredible possibilities. The journey of understanding string theory is not just about uncovering the secrets of the universe, but is also about expanding the limits of human imagination and creativity. As such, string theory is not only a theory about the small and unseen, but also about the vast and boundless possibilities of the cosmos. Section 5. Conclusion: Embracing the Unknown. String theory is more than a set of mathematical equations. It is a new lens through which to view the universe. It invites us to question and explore, pushing the boundaries of what we understand about the nature of reality. As we contemplate the universe through the vibrant landscape of vibrating strings, we realize that we are part of a much larger, more mysterious, and more intriguing cosmos than we had ever imagined. Reflecting on what string theory might mean for the future, it's clear that we are on the cusp of a new era in scientific exploration. The theory not only offers a more unified understanding of the physical forces and particles, but also opens up new realms of inquiry into the nature of the universe itself. Whether or not string theory proves to be the ultimate theory of everything, its development and exploration are crucial steps towards our greater understanding of the cosmos. As we move forward, embracing the unknown with curiosity and awe, string theory provides not just answers but also new questions. It reminds us of the beauty of the scientific endeavor, an endless quest not just for answers but for better questions. The journey through the strings of the cosmos is both humbling and exhilarating, offering a glimpse into the elegance and intricacy of the universe that awaits to be discovered. Ultimately, string theory is a testament to human curiosity and our relentless pursuit of knowledge. It encapsulates our desire to understand the fundamental truths of our existence and to reach for the stars armed with knowledge, imagination, and an unquenchable thirst for discovery. As we continue to unravel the mysteries of the universe, string theory stands as a beacon of hope and a promise of the incredible discoveries that lie ahead.
Thanks for tuning in. Remember to hit the subscribe button, give us a thumbs up, and drop a comment below.